Okay, we're going to look at a few questions from 10F2. I thought I would start with 2B here. This is a nice throwback to a question we've done earlier in the year. The way we did it before was to say, okay, we'll let x equal 0.161616 recurring. We'll multiply by 100. Right, just the reason we're going to 100 is so that we can multiply out basically by, I can see it starts repeating not at the tenths but at the hundredths. So I'm pulling that 16 up. And that allows me to realize that 99x is 16 and then express this as a rational number, as a fraction. Okay, but we could also think about this using geometric series, because we could write the 0.161616 recurring as they've done up here. We could say it's 0.16 plus 0016 plus 00, I'll put the decimal in here, 16, etc., etc. Or we could say that that's 16 on 100 plus 16 on 10,000, we're at the 10,000th, etc. Right? What's happening here is that T1 is 0.16 and the R value is 1/100th. That's how I'm getting between those terms. That's what we're multiplying, right? Right. Now, if we want to write this recurring decimal, this series would have to go on forever. It would have to be infinite. So I could say it's an infinite series, T1 on 1 minus R, where T1 was 0.16, and the 1 minus R, well, the R is 1 on 100th, that would be 99 on 100th, right? So just going over here, let's say our infinite series, or the sum of all these terms, is 16 on 100 multiplied by 100 on 99, right? So I'm doing this division here. I'm saying 0.16, that's 16 on 100, all divided by 99 on 100, and I got that from 1 minus R from the formula. Right, these hundreds cancel nicely. 100 divided 100 is 1, and we're just left with 16 on 99, which I've checked by this algebraic method over here. Right, so there's a nice, interesting application. Have I still got a pen? Yep, I do now. And it's a type of question you've done before. Question 3 I've actually done in a previous video. Question 4 we might look at as well. So let's look at 4b, just because it looks a bit like messier. Right. So if this was a sequence, we could think of find the sum of each of the following infinite geometric series. I'm going to put little commas in, right, just so I can see these are separate terms in a sequence. So if I was to then add them up, I'd have my series. The T1, 18.9, but what's the R going to be? Well, the R is the common ratio between successive terms. I can see the 6.3 is 1/3 of the 18.9, as in I'd have to times this number by 3 to get to the 18.9. There's also a negative there. Maybe we check that. If we look at term 3 and term 2, and excuse me, hopefully that's fairly clear that the R value is -1/3. All right, if I want to find the sum where this series is infinite, it will converge on a particular value. So let's do that. Where can I do it? Maybe up here. All right. So the infinite sum is T1 on 1 minus R. Right, the T1 was 18.9. The 1 minus R will be 1 minus a third, which is actually 4/3. Right. This is the same as 18.9 times 3/4, and that I've done that on my calculator, and it's come out to equal 14.175. So this series would converge in on this particular value. All right, and we might leave it there for this video.